All right, in just the next few minutes, we're going to totally demystify PySpark. This is the go-to tool for data engineers, and we're going to break down the absolute basics you need to get started, right from the ground up.
So, let's just jump right in. Why does PySpark even exist? Well, imagine you're not dealing with a little spreadsheet. Imagine you have millions, maybe even billions of records. Your own computer? It would just grind to a halt. So what do? How do you possibly handle that kind of scale?
You guessed it, the answer, used by pretty much every major company out there, is PySpark. It is the industry standard tool built for exactly this kind of big data problem.
Okay, so what is it really? The easiest way to think about it is this. Apache Spark is this incredibly powerful, super fast engine, and PySpark, that's just the steering wheel that lets you, a Python developer, drive that engine across a whole fleet of computers all at the same time.
Now, before we write any code, we have to understand the most fundamental piece of the puzzle. It's called a data frame. And trust me, everything, and I mean everything we do in PySpark is built on top of this one concept. And this right here, this is the absolute key difference. On the left, you've got your normal table, like you'd see in SQL or if you're using pandas. All that data is stuck on one machine. But a PySpark data frame on the right is a totally different beast. To you, it looks and feels like a regular table, but behind the scenes, its rows are spread out across a whole bunch of computers. That's its superpower. That's what lets it process enormous amounts of data in parallel. And look at this. Creating one is actually super simple. You see the code here? We just define our data and columns like we would in regular Python. But then that line, spark.createDataFrame, that's the magic. That tells Spark to take our little bit of data and spread it across the cluster. And then df.show, well, that's what tells Spark to actually get to work and show us the result.
Okay, so we've got our data loaded into a data frame. Now what? How do we actually do stuff with it? Filter it, change it, clean it up? Well, we do it by building a kind of blueprint, a set of instructions. And in PySpark, these instructions are called transformations.
So transformations are basically just your commands to Spark. Things like, hey, filter out all these rows, or add this new column, or I only want to see these 3 columns. And every single time you do one, you get a new data frame back.
Now we've arrived at the single most important and sometimes a little confusing concept for anyone new to PySpark. What on earth does it mean when we say that these transformations are lazy?
Just look at this flow. In step 1, you write some code to filter for anyone older than 26. Does Spark actually do the filtering? Nope. Then in step 2, you tell it to add a brand new column. Does it do the calculation? Still no. All that Spark is doing here is listening to your instructions and building a plan, kind of like a recipe of all the things you want it to do eventually. And that's the key takeaway right there. You're not actually running any jobs yet. You're just describing the work you want done. You're building a blueprint. Now, the fancy technical term for this blueprint is a directed acyclic graph, or a DAG. But all that really means is it's a step-by-step plan. And right now, 0 computation has happened.
So that leads to the obvious question, right? If all these transformations are just building a plan, how do we finally say go? How do we tell Spark to actually execute the plan and give us our result? Well, that's where actions come in.
And here's the difference in a nutshell. If transformations are the lazy blueprint, actions are the eager trigger. They are the commands that basically tell Spark, okay, that's it. I'm done giving you instructions. Take that entire plan you built, run it from start to finish, and give me the result now.
Okay, let's do a quick end-to-end example so you can see exactly how this works. We'll start with our simple little data frame with some names and ages. Now, we add our first instruction to the blueprint. We tell Spark that we want to filter this data to only include people older than 26. But remember, at this exact moment, nothing has actually been filtered. It's just a note in the plan. Then we add another step. We say, okay, on that data that you will eventually filter, I also want you to create a new column called age_double. So our plan just got a little more complex, but still, no work has actually been done.
And here it is, the big moment. The second we call .show, which is an action, Spark roars to life. It looks at the entire plan we've built. It thinks for a second about the most efficient way to run it, and then it executes the whole chain of events, the filtering, the column creation, all at once to give us that final output.
All right, let's really nail this down. If you're preparing for a data engineering interview or an exam, these are the concepts they are absolutely going to drill you on. I can almost guarantee this will be one of the first questions you get. So, how do you nail the answer?
It all comes down to one word for each: Transformations are lazy. They just build the plan, the DAG. Actions are eager. They are the trigger that tells Spark to actually execute that plan. Simple as that.
Okay, here's a slightly more advanced follow-up they might ask. Why does Spark even bother with this whole lazy approach? What's the benefit?
And the answer is all about performance. Because you give Spark the entire blueprint up front, it can be incredibly smart about how it executes your job. It has this brilliant internal engine called the Catalyst Optimizer. It analyzes your entire plan and figures out the absolute fastest, most efficient way to get you the final result, sometimes even reordering your steps to save time. So, let's just do a final recap of the absolute essentials. 1. Data frames are your tables, but distributed across many machines. 2. Transformations are the lazy blueprints you build to tell Spark what to do. 3. Actions are the trigger that makes the job run. And 4. Spark uses that plan, that DAG, to execute everything efficiently.
And there you have it. That's the core logic. Every single time you write PySpark code, you're just building a plan with transformations and then executing it with an action. So now that you've seen the blueprint, you're ready to go out there and start building.